So we've taken a look at vectors in the plane, and now we're going to take a little bit deeper look into vectors and the dot products. And so the dot products are basically when you're multiplying two vectors. And so essentially you're just multiplying the first term and then multiplying the last two terms and then adding them together. And you can see some properties of the dot products there in the box. A lot of them are very similar to properties really of multiplication. All right, so let's take a look at example number 1. Find each dot product. And so for part A, we're just taking those first two numbers and we are multiplying them. And then we're taking the second two numbers and multiplying them. So we have 6 plus 6, and that gives us 12. Pretty straightforward. Do the same thing for part B. So we have 2 times 1 plus 2 times negative 1. So we have 2 plus negative 2, which is 0. All right, so you go ahead and do the third one on your own. All right, so you can see the answer to part C, so you can check yourself to make sure you did that correctly. All right, let's take a look at example 2. We have 3 different vectors in component form, and we are finding each of these following expressions using different properties. And so for the first one, we're going to do that dot product first. So we have 3 times negative 2 plus 4 times 6. So we have negative 6 plus 24. That gives us 18. And then we need to multiply this W there, that vector. And so we're going to put that back in. And then really all you do is distribute that 18. So you have 18, negative 18. And there's your vector in component form. Okay, for B, the first thing I'm going to do is multiply out the 2 for this vector. So that one becomes 2, negative 2. The U stays the same. So then we're going to take the first term of the U, which is 3, multiply by the first term of the W. Then we take the second term of the U times the second term of the W. So 6 plus negative 8 is negative 2. All right, and then we have this one. So we know that that is the same thing as U times U if we square this. So that's like saying the square root of U times U. And then we can do that dot product there. So U times U is going to be 3 times 3 plus 4 times 4. And when we multiply that, we get 9 plus 16. And that's the square root of 25. So 5 is the answer. All right, let's take a look at the angle between two vectors. Okay, so when we want to find the angle between two vectors, we have these vectors going off in different directions. And so that opposite side is this positive vector minus the negative vector. Or, well, minus the other vector that's going in the opposite direction. Shouldn't call it a negative vector. So we can find that angle using this formula. Okay, and so if we want to find the angle between these two vectors in example 3, we know that cosine of theta is going to be equal to the dot product, so 3 times 1 plus 0 times 6, over the magnitude of U times the magnitude of V. And so that magnitude is really Well, we'll do this off to the side. Make it a little bit easier. Okay, so the magnitude of u is the square root of 3 squared plus 0 squared, which is really just the square root of 3 squared, so that's just 3. So we have a 3 down here. And then the magnitude of v is equal to the square root of 1 squared plus 6 squared, and so that is the square root of 37, and that's not going to be able to simplify. All right, but then we can simplify this. So we have 3 plus 0. So we have 3 over 3 square root of 37, which is really just 1 over the square root of 37, because those 3's can cancel. And remember that the cosine of theta equaled that. So if we want to find theta, then that's going to be equal to the inverse cosine of 1 over the square root of 37. And so when we plug that into the calculator, we get approximately 80.54 degrees. All right, orthogonal vectors are when you multiply or you do the dot product of the vectors and you end up with 0 as your answer. So let's see if these two vectors are orthogonal. So we have negative 12 times 5/4 plus 30 times 1/2. Well, negative 12 times 5/4, I would simplify that because 12 divided by 4 is 3, so I'm going to get a negative 15. And then half of 30 is 15. I get 0. So yes, they are orthogonal. All right, now we're going to take a look at some vector components. And we're going to look at the projection of one vector onto another, because these types of components can tell you how to find like the force that's being applied or the amount of work. And so when we have the vector u being projected onto v, we end up with this diagram that you can see here, where this w1 is that projection of u onto v. And then you can see up here where w sub 2 is equal to u minus that projection. So let's take a look at example 5. And here's just another way to write that projection if you need to figure out what the value is. So find the projection of u onto v, then write u as the sum of two orthogonal vectors, one of which is the projection of u onto v. Okay, so we know that our w sub 1 is the projection of u onto v, and we can start with that dot product. So we have negative 2 times 4 plus 1 times negative 9 over the magnitude of v squared. So that's going to be 4 squared plus 9 squared. Because remember, the magnitude of v is the square root of 4 squared plus negative 9 quantity squared, which is the same thing as 9 squared. And actually, I probably should put that negative there. Okay, so our numerator, let's see, we get negative 8 plus negative 9, so that's negative 17. And then 4 squared is 16. Negative 9 squared is 81, so that's going to give us 97. So that's the first piece, but then we need to multiply by our vector there. So that vector was 4, negative 9. Okay, and so then we can just multiply that negative 17/97. So we have negative 68 over 97, and then 153 over 97. All right, so then we need to write what is that W sub 2, because then we're going to need to add the two W's together. So let's figure out what that is. Okay, and so remember that we're just subtracting, so that's going to give us negative 2 plus 68 over 97. Remember, it's just because this was subtracting the negative 68 over 97, so it becomes positive. And then we had 1 minus the 153 over 97. So that's how we're going to subtract that. Now I'm just going to simplify a little. So negative 126 over 97, and then negative 56 over 97. All right, so now I have my two vectors, and so I am going to show that U is the sum of W sub 1 and W sub 2. Okay, so I am going to take this number and add it to that number, and I get negative 194 over 97. Then I'm going to take this number and add it to this number, and I get 97 over 97, which when you simplify those fractions, you get negative 2, 1, which makes sense because it's the same as the original problem. All right, let's take a look at a situational problem. A truck with a gross weight of 36,000 pounds is parked on a hill inclined at 10 degrees. So here is the road, well, not the road, but here is my hill that is 10 degrees. And I have a truck here. Apparently it's not sitting on top of the road. And I am a wonderful artist, aren't I? Actually, it kind of looks like a car going down the road. But anyway, so that's supposed to be a truck. It's an ugly truck, I know. And we want to know, in order to prevent the truck from rolling down the hill, what force must be applied to overcome gravity. Okay, and so I like my pictures. So I am going to drop a perpendicular, and then I'm going to pull up a perpendicular to this one, okay? And so now I know that because of similar triangles, this has to be 10 degrees here. So the force needed to prevent the truck from going down the hill is this little piece right here. This is that 36,000 pounds of weight that is pulling straight down. Well, this is my hypotenuse, this 36,000, and I'm looking for the opposite side from the 10 degrees. So I want to use sine of 10 degrees equals that W sub 1 over 36,000. And so just multiply that 36,000. And so W sub 1 is going to be approximately 6,251.3 pounds. And so 6,251.3 pounds of force must be applied to overcome the force of gravity. All right, let's take a look at example number 7. All right, so now we're talking about work. So to slide an object across a floor, a person pulls a rope with a constant force of 25 pounds at a constant angle of 30 degrees above the horizontal. Find the work done if the object is dragged 40 feet. So we have the object, we have the rope, and that is at a 30-degree angle, and the person is pulling that object 40 feet, and the constant force is 25 pounds. Okay, so we know that work is the magnitude of the force times the distance that the person is dragging that object across the floor. And so that magnitude of force is going to be your cosine of 30 degrees times your 25 pounds. Okay, and then remember the magnitude is that distance, so 40 feet. Okay, and so then that ends up being, when you put that in the calculator, about 866.03 foot-pounds. And so that would be the work done. All right, so remember that the cosine of 30, and really I probably shouldn't have labeled this as 40 feet. We're dragging it 40 feet, but that side is not 40 feet. That is actually, this side is that projection of PQ, vector PQ, onto F. So that is actually the numerator. So let's just call that magnitude. Yeah. Okay, and so that's going to equal the magnitude over that 25 pounds. Because remember, cosine is adjacent over hypotenuse. Right, and then you multiply the 25 pounds to both sides. So your magnitude is equal to the cosine of 30 times the 25 pounds. So that's where that came from.